Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss about the introduction to priority queue and binary heap in Java. So friends, what is a priority queue? So here you can see priority queue is a data structure that allows us to find minimum or maximum element among a collection of elements in constant time. So here priority queue data structure holds the collection of elements and it helps us in finding the minimum or the maximum element in a constant time. That means from the collection of elements we can find the minimum or the maximum element very fast in constant time. So usually priority queue supports these three operations. One is the insertion operation where we actually insert a particular key into the priority queue. So the second operation is delete max or delete min. So here you can see whenever we call delete max or delete min, what it does is if we call delete max, it return and remove the largest key from the priority queue, and whenever we call delete min, it removes the smallest key from the priority queue and return it back. Also friend, if you don't want to remove the largest and the smallest key from the priority queue, then we use the third operation, which is the get max and get min. So it simply returns the largest and the smallest key without actually removing it from the priority queue. And also friends, we will discuss more about the priority queue in our upcoming tutorials. Moving ahead. So friends, in our last slide we saw about the priority queue. So now we will discuss about the binary heap. So here you can see the binary heap is a data structure that helps us in implementing the priority queue operations efficiently. So whatever the three operations we discussed in our last slide about the insertion of key, delete max or min, and get max or get min, those operations are efficiently implemented with the help of binary heap. Also friends, a binary heap is a complete binary tree in which each node value is greater than or less than the values of its children. So why it is a complete binary tree we will discuss later. Below you can see that there are two binary heaps. One is the min heap and other is the max heap. And why we call it as a min heap? Because each node value is less than equal to the values of its children. So here you can see if we take an example of node having value 0, then its children, which is 7 and 3, have values greater than the parent. So here in the min heap the parent value is less than or equal to the value of its children. Also here you can see if we take a node having value 7, then both its children, which is 9 and 8, have values greater than 7. And if we take an example of 3, then both its children having values 5 and 6 have values greater than its parent. So here this property is true for each and every node of the binary heap. And here you can see in the max heap, each node value is greater than or equal to the values of its children. So here if we take the node having value as 9, then its children have values lesser than the parent. And similarly if we take the node having value as 3, then its both children is having values lesser than the parent. Similarly 6, which is the parent to 5 and 4, its value is greater than both 5 and 4. Therefore by this definition, a binary heap is a complete binary tree in which each node value is greater than equal to, which is the max heap, or less than equal to, which is the min heap, than the values of its children. So here you can see the binary heap has two types, which is the min heap and the max heap. So in the min heap, each node value is less than or equal to than the values of its children. And in the max heap, each node value is greater than or equal to than the values of its children. Moving ahead. So friends, as we discussed in our previous slide that binary heap is a complete binary tree. So what do we mean by complete binary tree? So here as per the definition, a complete binary tree is a binary tree where all levels are completely filled except last level, and last level has nodes in such a way that left side is never empty. So what do we mean by this definition is below you can see a binary tree. So here at the level 1 we have a node having value as 0. So this node will be having a left child and a right child. So at the level 2 we have these two nodes, which is 7 and 3. And till level 2 you can see it is completely filled because a node can have only two children. But as soon as we go to level 3, here we see that 7 has one left child and one right child. Similarly 3 has only left child and there is no right child. So here you can see a binary tree is completely filled except the last level. So this is the last level. So here you can see all the levels are completely filled except the last level. So here we can see there is no node, therefore it's not completely filled. And also it has one more property, that the last level has node in such a way that left side is never empty. So here you can see that whatever the nodes the last level is having, they are in such a way that left side is never empty. So by the left side we mean that in example 2 you can see that level 1 is complete, level 2 is complete, but level 3 is not complete, and the last level is not completely filled. But here you can see by the second property it says that last level has nodes in such a way that left side is never empty. So here you can see one left side is empty. So therefore it's not a complete binary tree. So we call it an incomplete binary tree. Though its last level is not completely filled, but there is one missing left node. And similarly here you can see that all the levels are completely filled and the last level is not completely filled, but it has nodes in such a way that the left side is never empty. So friends, here you can imagine complete binary tree in such a way that if we go from left to right, then we always get a node. So here at the level 1 there is one node. So level 1 is completely filled. As we go to level 2, there can be at most two nodes. So here you can see if you go from left to right, we are getting 7 and 3. So those are completely filled. If we go to third level, if we go from left to right, then we are always getting a node. Though there is no right child of 3, but still it's a complete binary tree because there are no gaps if you are traversing from left to right. And similarly if we talk about incomplete binary tree, and if we go from left to right, then here we can see that 3 has no left child, therefore the first node is null. So it doesn't satisfy the property of complete binary tree. Also friends, in our upcoming tutorial, we will also discuss more about the complete binary tree, because this is the main property which helps us in creating a binary heap.